Hello everyone, welcome to PE Academy, and in this video we are going to be looking at mesh analysis. So I'm going to be taking you step by step what mesh analysis is and how to simplify circuit or answer questions that has to do with mesh analysis. So to start with, when we look at mesh analysis, one of the principles that we apply in solving mesh analysis is the Kirchhoff voltage law. And if you want to know more about that Kirchhoff voltage law, I've done a video that explains what it is all about. But we are going to be using that principle in solving questions under mesh analysis. And in mesh analysis, most times what you'll be asked to look for is either the current in a particular mesh or in a particular element in the circuit and so on. So with that now, let's get started with mesh analysis. So what we are going to be having here is, let me draw a circuit. So let me just draw this simple circuit here, just to use it to analyze what mesh analysis is all about. So one thing I'm very sure of, that at the end of this video series under mesh analysis, I'm very sure that you'll be able to solve any question that have to do with mesh analysis. That I'm very sure. So if that interests you, you can click on that subscribe button that is at the lower right of your screen if you are yet to subscribe to this channel, PA Academy. Alright, so thank you very much if you have just subscribed. Now let's come back to this circuit. Now this circuit that we are having here, so let me point out some of the nodes. And then let's call this is the voltage source 1, and then this is another voltage source. So if you watch the video under Kirchhoff voltage law, you should be familiar with this circuit. So this is R1. Let's call this R1. Let's call this R2, and then let's call this R3. And then what we do now, like I said, we are going to be applying the principle of Kirchhoff voltage law. So if you have this circuit and you have to apply Kirchhoff voltage law, what did I say you do? You are going to pick your direction of your current in each of this mesh. Now look at it, we call it mesh analysis. And if you look at the definition of a mesh is a part. It is a part, a single part in a circuit without having another part in it. Are we following? That's why we call it mesh analysis. So if you have this circuit, we have two mesh. This is a mesh, this is one mesh, and this is another mesh. So in this first mesh, let's pick the direction of our current. So let's take it in a clockwise position. I always take it in clockwise position. Since this is one mesh, I'll call it I1, the current in this particular mesh. Now for this second mesh, you can take the current position and let's call it I2, also clockwise. So this is mesh 1, and this is mesh 2. So I've done a video that explains what is a mesh, the difference between a mesh, a loop, elements, node, junction, branches, and every other thing. So the link to that video, you find it in the description of this particular video. So now if you have this circuit like this, now that we've picked our current, the direction of our current as clockwise, the next thing I want us to do is to give each element their polarities. Now this resistor here, they are what we refer to as elements. So in a circuit, you can have either resistor, capacitor, and any element. The steps are still the same thing. Now let's start with the voltage source. Now the voltage source, the polarity of the voltage source is not influenced by the direction of the current. I hope that is clear. So for the voltage source, the longer side is always the positive, while the shorter one is negative. So that means this place will be positive and then negative. So now let's go to the elements that we are having in this circuit. Now from the resistor, since it's only resistor is the only element, you can have a circuit having capacitor with it, an inductor, and any other elements. Alright, so in a clockwise direction, remember that, let me also say it here, when you are dealing with Kirchhoff voltage law, if you are moving in clockwise direction across a particular element, let's say in this like this. So let's take this to be our R1, for example. Let's bring this out. If this is our R1, if our current direction is like this, that's the direction of our current. So that means the polarity that we are going to be having for this resistor is going to be plus to minus. That's because it is going in this direction. But if you are having it, if you're having an element like this, and then the direction of the current is in this direction, and this is our current direction, and this is the element, let's call it our R1. So that means our polarity is going to be what? Plus, minus. So this is going to be plus, minus. Same thing apply if it is vertical. So let me put in, so let's say we have a resistor here, and then we have a current moving in this direction. So this is our current. So that means the polarity here will be plus, minus. So if it is upward like this, then and this is a resistor, that means the polarity will be plus, minus. I hope this is clear. And once you are able to understand it, it's also going to determine if it's a voltage drop or a voltage rise. I've explained this under Kirchhoff voltage law, but I felt I should just talk about it here. So once we continue in this calculation, you will understand it proper. All right, so with that being said, now let's now give polarity to the R1, R2, and R3. So in this direction now, that means it's going to be plus and minus. So also in this same direction, I'm looking at the mesh 1 now. In this same direction for R2, you are going to be having plus, minus. So then this is the next element you're having here, but the polarity is already given. So now let's go to the mesh 2. For the mesh 2 now, if you are starting from here, you go around and come back. So now the polarity for R3 will be plus, minus. So there's no other element here. So for this also, we are going to be having the polarity of plus and minus. Now if you look at the resistor R2, you know there are two currents that is passing through it. We have I1 and I2. So that means it's going to have two different polarities. You can see there's a polarity because of the I1 current that is passing through it. There's another polarity here because of the current I2 that is passing through this resistor. So now what we do now is we simplify each mesh 1 and mesh 2 separately using the Kirchhoff voltage law. So in doing that, so for mesh 1 now, so let me write it out. That's mesh 1 for mesh 1. So now let me call this point, this node A, B, C. Let me call this point D, E, and F. So for mesh 1 is A, B, E, F, and back to A. So this is the mesh we are looking at now. So let's start from point A. So from point A now, if you look at, we're having R1 here, and then the current, you know, the current that is flowing through it is I1, and we're having R1. So by the time it gets here, that means the voltage here is going to be, remember from plus to minus, that is going to be minus R1 times I1. So that will be R1 times I1. So this is the voltage here. Remember, this represents voltage. Remember, V is equals to IR. So we have our I and we have our R. This represents the voltage. And the negative here is, like I said, is because we are having the polarity is going from what? The direction of current is going from positive to negative. So that's why we are having negative here. I've explained all this under Kirchhoff voltage law. Alright, so let's continue. Since we are done with this, from B, we come down to going to E. We already have another element here, which is R2. So in the direction of currents, that is going to be from plus to minus. That will be minus R2, and then the current I1. That will be minus R2 I1. So let's now, before we move further, there is also another current that is passing through this R2 resistor. That is because of that's current I2 is also passing through this resistor. We are also going to consider that. Now in this direction, it is now from positive to negative, but the current is I2. I hope you get that. So that will now be plus R2 I2. That's this current. So then from here we continue like this, come to F, there's nothing here. From F to A we have a voltage source, from that is minus to plus, that is going to be plus Vs1, and then equals to 0. Alright, so if you simplify this further, we can, since we have I1 and I1 is common here, so we can bring it out and having minus I1 into brackets R1 plus R2 plus R2 I2 plus Vs is equals to 0. So I just want this Vs to be on the other side of the equation, and I want it to be positive. So if I should, in doing that, I'm going to be having Vs is equals to I1 into brackets R1 plus R2 minus R2 I1. And this, let's take this as our equation 1. Alright, so this is supposed to be I2. Alright, so there's one thing I did remember to mention at the beginning, is that what we are actually trying to calculate is, if you have a circuit like this under mesh analysis, and you are asked to calculate the current, that is in each mesh, that means the value of what you're actually looking for is find the value of I1 and I2. So we are also going to be looking for the value of the current that is passing through R1, R2, and R3. That is IR1, and the current that is flowing through the R2 resistor, and the current that is flowing through the R3 resistor. So that's basically what we are looking for. I forgot to mention it. So we've gone through the first step by analyzing mesh 1. Now we are also going to analyze mesh 2. This is the mesh 2. So now for us to analyze mesh 2, we are going to take it from point B, and we are going to go round the mesh. So let me write here that for mesh 2, and then the path for mesh 2 is B, C, D, E, and back to B. So that's B, C, D, E, B. So applying KVL, so let's start from B, and the next is the elements that is coming. So that's going to be minus, the current is I2, minus I2 R2. Then from here, that's going to be minus VS1, from plus to minus, minus VS1, that's voltage source 1, come here to D, and from D to B, we already have R2, and from plus to minus, that is going to be minus I2 R2. Sorry, this is supposed to be R3. Now also, we also have I1 is also affecting this, is also passing through this R2, but in this direction, that's from plus to minus, we are going to be having plus, and then the current is I1 plus I1 R2 and back to B, all equals to 0. So now by the time we simplify this, we are going to be having, so let's look at it. So we have I2 is common here, and I2 is common here, so we can have minus I2 into brackets R2 plus R3, R2 plus R3, then plus I1 R2 equals to, so if this minus VS1 come to the other side of the equals to sign, it's going to be VS1. And this we are having here is our equation 2. Equation 2. Now the reason why we are having alphabet is, by the time we start looking at example, especially in the next part of this video, we start looking at example where we are going to be having real figures. We are going to have a clear understanding of all what I'm writing on the board. Now with this equation 1 and equation 2, if you should solve, so by solving equation 1 and 2, equation 1 and 2 simultaneously, by the time we solve it, we are going to get the value of I1, and we are going to get the value of I2. Remember, that's what we are looking for. Find the value of I1 and I2. We are going to get the value. Also, by the time we get the value of I1 and I2, for us to get the current that is now passing through each of these resistors. Now, let's say we already get the value of I1 and I2, and we are to calculate the current like that is passing through each of these resistors. So let's start with I1. So let's say we want to calculate the current that is flowing through R1 resistor. Now from what we are having here, the current that is flowing through R1 resistor is nothing but what, through R1 is I1. So that means the current that is flowing through R1 resistor is what, is I1. So don't worry, when we start to look at real example using number, you are going to have a clear understanding, but this is just basically the concept behind mesh analysis. So that's for I1 and IR1. So now then for IR2, so if you have to calculate the current that is passing through this R2, this resistor R2. Now if you look at it, there are two currents that is passing through it. We have one current like this, that is I1, and we have another current like this, I2. Now, depending on the value of our I1 and I2, the current that is passing through here can either be I1 minus I2. Remember, there are two currents passing through it, or I2 minus I1. I hope you can still see that. Okay, so it's not showing. So it's either I1 minus I2 or I2 minus I1. Now, what will determine which will come first is the one with the highest value. So if at the end of the calculation, the value of your I1 is more than I2, this is what you are going to use. But if I2 is more than I1, this is what you are going to use. So don't worry, when we start using examples, like I said, you are going to get it. So now let's look at R3. For the current that is passing through the R3 resistor is nothing but I2. So that's I2. So now what I've just shown you now is just the basic concept that's behind mesh analysis. Whenever you are looking at mesh analysis, for mesh analysis, once you have your circuit like this, you identify the number of meshes you have in the circuit. Like this, now we are having 2. Then you apply Kirchhoff voltage law to each of those meshes. It's going to give you different equations. So if you have 3 mesh, there's a possibility that you have 3 different equations. If you have 2 mesh, you have 2 equations like I'm having here, all things being equal. Then using simultaneous equation or any other means, you'll be able to get the currents. And depending on what they are asking you to look for, maybe you're asked to look for the current in each mesh, or you asked to look for the current in any of the elements in the circuit. So once you understand this, then you'll be good to go. So in the next video, I'm going to be looking at different examples on how to apply mesh analysis. And it's also important for you to understand this concept, because some question can ask you to simplify a circuit or to find the current that is passing through any particular element, stating categorically or specifically that you should use mesh analysis. Now, for you to get I1 and I2, there are other methods that you can apply, but some question can ask you that use mesh analysis. So it's very important for you to understand this. So I still have 5 more examples that I'm going to be taking you through, so that you can have a full knowledge and understanding of what mesh analysis is all about. So if you have any question with what I've shared with you so far, do leave them in the comment section below. And if you are new here, please consider subscribing to this channel, PA Academy. It's absolutely free. And if you want to have more knowledge about how to solve Kirchhoff voltage law, or you want to know more about Kirchhoff voltage law, I'll leave a link to it in the description of this particular video. So with that, guys, I'll see you all in the next part of this video, where we are going to be looking at examples. Thank you.